Our report is about performance tests of a positive displacement pump. Positive displacement pump is a type of pump in which a moving fluid is captured in a cavity and then discharged that fixed amount of fluid. So it's just like transferring of fluid from one place to another. So we have positive displacement pumps can be divided in two main classes. So we have reciprocating and rotary. Under reciprocating pump works by the repeated back and forth movement stroke of either a piston, plunger, or diaphragm. So when we say back and forth, it's just like a push and then pull and then push something. Next, types of reciprocating pump. So first, we have piston pump. The first stroke of the piston creates a vacuum, opens an inlet valve, closes the outlet valve, and then drawn fluids into the piston chamber. The mechanism consists of a reciprocating piston inside the cylinder with a check valves with both inlet and outlet. When the piston is on its suction stroke, which is the upstroke, the chamber inside of the cylinder expands, the pressure drops, the check valves on the suction sides open when fluid is admitted to the inlet. The check valve permits flow only in one direction to prevent backflow. As the valve on the suction sides opens, the valves on the discharge valves closes. On downstroke, the piston pushes the fluid. The suction valve now closes and the discharge opens to release fluid. Next, we have plunger pump. Plunger pump operates in a similar way. In a plunger pump look very similar to piston pump, but they work a little differently. Unlike a tight fitting piston, plunger pump fits loosely to its cylinder. The physical mass of the plunger holds the size of the chamber and displaces the fluids. Next, we have diaphragm pump. Diaphragm pump uses flexible membrane instead of a piston or a plunger to move a fluid. By expanding the diaphragm, the volume of the pumping is increased and fluid is drawn into the pump, compressing the diaphragm, decreasing the volume, and expels some fluid. Unlike a piston or a plunger, an elastomer diaphragm is flexible. When it flexes, it changes the volume of the chamber, causing the fluid to be drawn into or pushed out of the chamber.
Hi, I'm Jan Philip Zambrano and I'm going to present to you the types of rotary pumps. But first, rotary positive displacement pumps use the action of rotating cogs or gears to transfer fluids, rather than the backward and forward motion of reciprocating pumps. Gear pumps are kind of rotating positive dislocation pump, which means they force a stable amount of liquid for every revolution. These pumps move liquid for making a non-exciting pump act. A gear pump uses the meshing of gears to pump fluid by displacement. They are one of the most common types of pumps for hydraulic fluid power applications. The gear pump was invented around 1600 by Johannes Kepler. Gear pumps are also widely used in chemical installations to pump high viscosity fluids. They are also preferred in applications where accurate dosing or high pressure output is required. Vane pump is a positive displacement pump that consists of vanes mounted to a rotor that rotates inside a cavity. It uses the back and forth motion of the rectangular shaped vanes inside slots to move fluids. The rotor is sealed into the cam by two displaces. Vanes or blades fit within the slots of the impeller. As the rotor rotates and fluid enters the pump, centrifugal force, hydraulic pressure, and or push rods push the vanes to the walls of the housing. The fluid then exits the discharge port. Lobe pumps. These pumps can be related to gear pumps, apart from the lobe, which do not approach into contact to each other, offer different characteristics like an excellent high efficiency, rust resistance, hygienic qualities, reliability. As the lobes comes out of mesh, they create expanding volume on the inlet side of the pump. Liquid flows into the cavity and is dropped by the lobes as they rotate. Peristaltic pump, or are also named as tube pumps. Peristaltic pumps, it makes a stable flow for measuring and bending and also capable of pumping a variety of liquids like toothpaste and all kinds of chemicals. A rotating show or roller passes along the length of the house or tube, creating a temporary seal between the suction and discharge sides of the pump. Screw pump, also known as water screw, is a positive displacement pump that uses one or several screws to move fluids or solid along the axis. The screws take in fluid then push it out from the other while increasing its pressure. Due to their ability to provide high flow rates even in viscous liquids, screw pumps are ideal for fuel transfer, elevators, and other similar industrial applications. Single screw pumps or Archimedean screw pumps are used for simple water movement such as for sewage inlet pumps, stormwater pumping, drainage pumping, and to move industrial wastewater.
John Valdez for the continuation of the report at the performance test of a positive displacement pump group number 12. My report is rotary progressive cavity pump. Progressive cavity pump is a type of a displacement pump and is also known as a cavity pump. It transfers fluid by means of progress through the pump of a sequence of small, fixed-shaped, discrete cavities as its rotor is turned. So, in rotary progressive cavity pump, it is similar with screw pump, but a progressive cavity pump is used when the pumping application is not suited to a centrifugal pump. One of the clearest examples of when to use a progressive cavity pump is when the liquid has higher viscosity or thickness than water. Working principle of a positive displacement pump. Positive displacement pump. A positive displacement pump has a expanding cavity on the suction side and decreasing cavity on the discharge side. Liquid flows into the pump as the cavity on the suction side expands. The liquid flows out of the discharge as the cavity collapses. The volume is a constant given each cycle of operation. A positive displacement pump must never operate against closed valve on the discharge side of the pump. It has no shut-off head like centrifugal pumps. A positive displacement pump operates against closed discharge valves continues to produce flow until the pressure in discharge line increase until the line burst of the pump is severely damaged. It is a constant flow machine. So in positive displacement pumps, positive displacement pumps can be classified by rotary and reciprocating, and depends on these two classification. Then the principle may be different also. So in rotary positive displacement pumps, by terms of rotating components, the fluid will increase its acceleration, and by reciprocating positive displacement valve pumps, and this is by means of placing forward and backward instead of rotating components. Positive displacement testing. Positive displacement pump testing will be done at 25, 50, 75 and 100% of the rated pump speed, and at pressure as near to the rated pressure as possible. The measured quantities will be used to generate a pump performance. Where possible, the pump will be tested at the speed at which the end user will operate the pump. In some cases, they will be tested at a reduced speed, and affinity loss and other statistical method will be used to generate a curve at the end user speed. If possible, tests shall be run at both the rated discharge pressure with reduced speed and at the rated speed with reduced discharge pressure. Performance testing is a way of testing the pump's performance by measuring pump speed and pump pressure. This can be plot on pump performance curve that can be used, and other statistical method.